What is stoichiometry? It's a method to calculate amounts of reactants and products in a chemical reaction. First, you must know some concepts like writing formulas of chemical compounds, writing and balancing equations, what's an atom, a molecule, and a mole, what is molar mass and molar volume. You must know how to calculate with rules of three and proportions, and how to calculate percentage. What are stoichiometric relations? Let's take this model reaction. If you look at the amount of elements on each side, you will see that this is not balanced. I have, for instance, 2 chlorides here and 3 here, and 4 phosphorus, 1 here, so we will balance adding these numbers. These numbers are called stoichiometric coefficients. When there is none, it means there is a number 1 in here. So these numbers are the same as thinking amounts of moles of those substances. Here, 1 mole of phosphorus, 6 moles of chlorine, and 4 moles of this product. If the substance is a gas, only a gas, you can make an equivalency between the mole and the volume of 22.4 liters. That is only for gases in standard pressure and temperature conditions, that is 273 Kelvin and 1 atmosphere. You can also think of this reaction as amounts of molecules reacting. Remember that 1 mole has an Avogadro's number amount of molecules, and if you have more moles, like in this case where there's 6, you should multiply the number of Avogadro by 6, and in this case by 4. You can also think of the grams reacting. There is a direct relation between the moles and the molar mass of the substance. Here, let's see that you have 6 moles of chlorine, so you should multiply the molar mass of chlorine, that is 70 grams. You should multiply it by 6, and here you should multiply it by 4. So, for example, it is true to say that 1 mole of phosphorus, or 124 grams, always must react with at least 6 moles of chlorine to give 4 moles of phosphorus chloride. That's one example. You can make other examples relating grams with grams or grams with molecules. What I mean by this is that you can relate moles, grams, molecules or atoms, and liters of gases even, as long as you respect the stoichiometric relation. There's a first case when in a problem you will have data about only one substance of all the substances involved. Like in this one, how many moles of hydrogen are produced when 1.85 grams of aluminium react with hydrochloric acid. In this case, all you know is how much aluminium you have, nothing else. So let's establish which one is our data and which one is our unknown. This is the data and this is the unknown. Look at the question, it says how many moles. So that is what I am interested in, not grams, not amount of molecules, but moles. So now we are going to establish a stoichiometric relation between aluminium and hydrogen. The best is to respect the same unit of the data in the stoichiometric relation. If you look up aluminium in your periodic table, you will see it weighs 27 grams per mole. But here are 2, so you should multiply that molar mass by 2. And in the amount of moles, we know that the coefficient here is equivalent to the moles, so here goes 3 moles. Is it wrong to put here 3 times the molar mass of hydrogen? No, it's not wrong. It's the same. If you put here instead of 3 moles, 3 times 2 grams, that is okay too. But you won't have the answer directly. You would get grams and not moles. That is what the question is asking. So now you pose a proportion between the data and the unknown. First, you start with what you know, that is up here. You know that 3 moles of hydrogen come from this mass of aluminium. So the mass of aluminium that I have, how much hydrogen? Case 2. Data about 2 reactants. When you have amounts of 2 reactants and you want to know how much product you get, first you must calculate the limiting reactant. That is the one that is consumed first. To understand this concept, let's take a look at this practical example. If you want to make a hamburger, you will need 1 piece of meat and 2 slices of bread. So if you have, for example, 5 pieces of meat and 10 slices of bread, you will make exactly 5 hamburgers. In that case, it is said that they are in stoichiometric amounts because nothing is left over. But what happens if I get 23 pieces of meat and 14 slices of bread? How many hamburgers can I make? So let's choose one reactant, anyone, and calculate how much of the other is needed to consume it all. I choose the meat, so I say that I need 2 slices of bread for 1 meat. If I have 23 meats, how many breads? I would need 46. So now I have to compare with what I truly have, that is 14. I would need 46, but actually I have only 14. So I have less bread than what I really need. That means that bread is the limiting reactant. So now I can use what I actually have of this reactant to calculate the product. I know that 1 hamburger comes from 2 breads. If I have 14 slices of bread, I can only make 7 hamburgers. And of course, I will have many meats left over. Let's go and calculate a limiting reactant in a true reaction, like in formation of water. How many grams of water are formed by reaction between 12 liters of hydrogen in standard conditions and this amount of molecules of oxygen? First, our data and what is the unknown, and now the stoichiometric relation in the same units than the data. Here in the hydrogen, I know I have 12 liters, and the stoichiometric relation is here only 1 mole. So how many liters are 1 mole of gas if I am in standard conditions? 24.4. The oxygen is given in number of molecules, so the relation I have with number of molecules is the Avogadro's number for 1 mole. But I don't have 1 mole of oxygen in my reaction, in my stoichiometric relation. I have only a half of a mole, so it is a half of an Avogadro's number. And the mass of water is 18 grams. I want it in grams because the question is how many grams of water. Now we calculate who is limiting. I choose, for instance, to calculate how many molecules of oxygen I need for all the hydrogen I was given. Here is the stoichiometric relation between what I want to calculate and the data. In this case, I need this amount of molecules of oxygen. Now I compare what I need with what I actually have. Look that there is less than what I actually have. I need less oxygen than what I was given. So that means that O2 is exceeding and hydrogen is limiting. Now I can calculate the amount of product using the limiting reactant in the same way as we did in the case 1. I establish the relation between the product and the limiting reactant. I have to look at this and this. I don't care about this anymore. And then I multiply it by the amount that I actually have of hydrogen. Thanks for watching. You know, you can like, comment, and subscribe.